Okay, so looking at example 3, we're asked to calculate more partial derivatives, except we'll see that we're going to have to apply the various differentiation rules if it's necessary for a particular function. So like the product rule, the quotient rule, the chain rule, and so on and so forth. In particular, this function will require the chain rule. Okay, so let's take a look first at the partial with respect to x. So the partial with respect to x. So I'm treating y as a constant, right? So the derivative of the exponential function is just the exponential function, except in the exponent, I have more than just x, so I have to apply the chain rule here, right? So the derivative of what's inside here, treating y as a constant, so this is just a constant times x, meaning the derivative of the inside would be the coefficient, which is y. Okay, and then here, x over y, I'm treating y as the constant, right? So I can think of x over y as 1 over y times x. Right? So this is the same as this expression. So if y is a constant, then this is just a constant times x again. So the derivative would be the coefficient, which is 1 over y. And then typically for something like this, you put the y in front. So this can be written as y e to the xy plus 1 over y. Okay, so that's the partial with respect to x. And then continuing to the partial with respect to y now, I treat x as a constant. So here again, the derivative of the exponential function is the exponential function, but I have to apply the chain rule here. So the derivative inside, I'm treating x as a constant. So this is a constant times y, meaning that the derivative of the inside should be the coefficient, which is x. And then for this part here, so now I'm thinking of y is the variable and x as the constant. So now I'm going to rewrite this as x times, my pen is bleeding. So x times y to the minus 1. So I'm going to rewrite this in this form, so that now when I differentiate with respect to y, this is just the power rule, right? So the minus 1 comes down, and then I have the x is the coefficient, times, and then I subtract 1 from the exponent. So negative 1 minus 1 gives me a negative 2. Okay, so that's the derivative, and then I can rewrite the answer in this way. So y to the negative 2 goes into the denominator, so that becomes x over y squared. Okay, so that's the partial derivatives for example 3.